In this presentation, we're going to explain the concepts behind floating and sinking that correspond to the lesson that we're writing to support the NGSS performance expectation about second grade properties of matter. There's three basic rules that we can use to explain why things float or sink. The first rule says that if objects are the same size, then increasing the weight makes it more likely to sink. The second rule is that if we have the same material or stuff, changing the size does not affect whether it will float or sink. And the third rule says that for the same material or stuff, changing the shape can affect whether it will float or sink. We're going to look at each of these rules individually. For rule number 1, that when an object's size is held constant, increasing the weight makes it more likely to sink, is related to the idea of density. Density is equal to mass divided by volume. So, if we increase the weight, or the mass, while keeping the volume constant, then this is going to make the density larger. And if the object is more dense than the liquid it's in, it will sink. A way that we can develop this rule with students is to do the experiment that we did in class with the plastic eggs. Using the plastic egg keeps the size or the volume the same, but by adding the marbles one by one, we can gradually increase the weight and show students that when the object is the same size, increasing the weight makes it more likely to sink. For rule number 2, if the material or stuff is the same, changing the size does not affect whether it will sink or float. This idea is because of density. If the density of the material stays the same, in other words, if it's a potato like we showed in class, if you change the size of it by cutting it up, you're not changing the density. You're not changing the ratio of mass per volume, so it will still sink as the potato did originally, or if it, in the case of the apple, it would still float. So if the stuff is the same, changing the amount does not change whether it sinks or floats. So to develop rule 2 with students, we could show them that if we started with the whole apple, which floats in water, even if we cut it up, it still floats, no matter how we cut it up. Or with the potato, it sinks, and no matter how small we cut it up, it still sinks, because whether the object sinks or floats depends on the properties of the stuff, which in this case is how heavy it is for its size, which we know is density. The third rule is that if the material or stuff is the same, then we can affect whether it will sink or float by changing its shape. This is the idea behind the probe that you used with the students on sink or float. So we could take a dense material and make it float if we make it into a shape that builds in an interior volume of air, such as a boat or a bowl. Because what we're really doing is lowering the average density of that shape, because the volume now includes both the volume of the clay plus a volume of air. So to develop rule number 3, we could have students do the activity from the probe, give them 2 equal masses or weights of clay, and have them compare different shapes to see whether it will sink or float. They should find that if they make a boat, that they can make it float, but if they make a solid ball, it would sink. Now, one of the challenges of teaching sinking and floating is that students at the age we're looking at second grade, are not yet capable of understanding density. It's really a middle school concept that involves a ratio of mass divided by volume, which is a little bit complicated for second grade. So we're going to avoid using the term density. But what we can do is talk about objects being heavy or light for their size. So if we keep the size the same, like we did in the egg experiment, we can talk about it being heavy or light for a given size. So the problem is, if we try to compare objects that have a variety of sizes, shapes, and materials, we're changing more than one variable at a time, which means it's going to be hard to infer any kind of cause and effect relationship by comparing those objects because more than one thing is changing. So it's important when you're thinking about your sinking and floating lesson to think about fair tests of the different variables. Okay, so to recap, there's basically 3 rules that I've come up with for floating and sinking. Rule 1, when size is the same, the heavier it is, the more likely it'll sink. Rule 2, when the material is the same, changing the size does not affect whether it will sink or float. And rule number 3, when the material is the same, changing the shape can affect whether it will sink or float. And those 3 rules can be developed through the series of experiments that we talked about in this presentation.